Okay guys, we are here for Unit 3, Lesson 3, and now we're looking at linear over linear rational functions. So as you can see, we're slowly kind of building on this idea. We started with just reciprocals of linear, so just 1 over a linear function. Then we looked at reciprocals of quadratic, so we had linear over, 1 over a quadratic. Now we're looking at linear over linear. You might see where we are progressing to. Eventually we will get to linear over quadratic or any degree. So at the end of this unit, you understand how to find the asymptotes and end behavior of a function that is the quotient of two linear expressions. So, rational functions that are in the form ax plus b divided by cx plus d. This is not overly important because I don't love this notation, but what is to note is that you have some coefficient of the linear function of the numerator, some constant of the linear function that is the numerator, a coefficient of the linear function in the denominator, and a constant of the linear function in the denominator. So to start, we're going to look at this function, this rational function 2x minus 3 over 5x plus 6. So this is the quotient of two linear functions. First linear function 2x minus 3, second linear function 5x plus 6. And I'm going to show you the graph right off the hop, and then we are going to talk about the vertical asymptotes and the behavior around those asymptotes, horizontal asymptotes and the end behavior of the function, x and y intercepts, domain and range, and then a sketch. We've already sketched this one, or we have a graph of it because I just to make some connections. So I want you to, again, you could pause the video and take a look and see what you can see. And actually, I wanted to show you, like, that's what the graph looks like zoomed out, just so you have a better look, and zoomed really close into where we see some of those asymptotes. Let's just do two things here. Let's group these together and pull this up here so that you can see it with the questions. So what do you maybe notice? Let's just get rid of that one for now. About the vertical asymptote, horizontal asymptote, the behavior around those asymptotes, the intercepts. So now we have an x-intercept. We haven't seen that before. We also have a y-intercept here. So lots of things going on, and some rules still apply from our reciprocal functions, and some are completely new. So take a minute. Do you notice anything between what you see here in the equation and what you see here on the graph? Okay, so pause your video, take as long as you need. And if you're coming back, hopefully you've taken a look. I am going to point out some things. So we have a vertical asymptote happening right here. Now, if this is -2, this is -1. So some amount that's a little bit greater than -1, we have a vertical asymptote. Now, the same rules still apply. This is still some function that cannot be divided by 0. So notice that for A, for our vertical asymptote, our vertical asymptotes still happen when the denominator, I'm going to use short form, is equal to 0. That hasn't changed. So we're still going to say, okay, when 5x plus 6 is equal to 0, we do opposite operation, so -6 on both sides, divide by 5 on both sides. X is equal to -6 over 5, which is -1 and 1/5, which is -1.2, which we said this is -1, and it's just a little bit further than -1. So at -1.2, we see a vertical asymptote. So that is one really important piece of information, is that vertical asymptote. Now, what we can't use is our understanding of the relationship between reciprocal and original functions to determine the behavior, knowing that on the left of this asymptote, we're approaching positive infinity, and on the right of this asymptote, we're approaching negative infinity. So what we actually have to do for this part here, the behavior around the asymptote, is we have to actually sub in something that is to the left and something that is to the right. And so it does require some substitution, but we could say, okay, what about f at something to the left of this, -1.25, and something to the right of it, f at -1. If this is -1.2, then we're going this way, so -1.15, I don't know, whatever we want to do. So you would have to actually get out your calculator, sub in those values. I have not already done this. Do I even have my calculator close by? So what we're going to do is we're going to use Desmos, 2x minus 3 and 5x plus 6, 2x minus 3 and 5x plus 6, and this is f at x, and I don't know what that is.